Okay, welcome to class, everybody. I apologize for the time change, but my schedule has changed on me unexpectedly. So from here on out, I think we're going to be going 7:30 to 8:30 instead of 7 to 8. So before I start into the new material, I was planning today on going over assignment 6, and then after that, introducing lab 7 and assignment 7, and then starting to cover the material that you're going to need to know in order to be able to complete those. But is there anything anybody would like me to answer before I start reviewing assignment 6? If so, please indicate either in the chat or just start talking. Can I get some indication that you guys can even hear me? Because I don't know if I'm not hearing anything.
We can hear you.
Okay, all right. So just nobody has any questions? Okay, well, then I'm going to go ahead and, well, actually, let me ask this. Is it worth it for me to, okay, somebody talks about Canvas. Is it worth it for me to work through assignment 6 really quick? Does anybody want me to do that, or is that not necessary?
I think it'd be worth it.
Okay, all right. So let me pull it up really quick here. All right. Let me share my screen. All right. And the chat up here. Minimize this. Okay. All right. So let's go ahead and work through assignment 6. So, all right. So the first thing that we need to do is we need to create these classes. So we got generic shape class that has this color attribute and then the 3 subclasses. Okay. So let's go ahead and create a new file here. Programs, Python. All right. Looks like I've already got an assignment 6.py. What's this? Oh, okay. This is just, all right. I'm gonna start from nothing. We'll just do this whole thing. All right. So we're gonna start off. We have a shape class. Okay, and it's gonna have an init method. And right now, the only thing that it looks like that it takes is color. So we'll do self.color equals color. And do we know anything else about that?
The default color is black, I believe.
The default color is black. Okay. No other methods or attributes are needed. So all I have to do to make the default color black is just do this color equals black. Okay. All right. So there we go. We're done with our shape class. All right. Now we're going to have a circle. We're going to have, well, I'll just wait to do the other ones. Okay. So let's start with, I think circles next, right? Okay, so we got X, Y, and radius, and it should have a constructor. Okay, so copy some of this stuff here. So we'll do X, Y, radius. And I guess we probably also want to have a color. We'll just call this we're going to use the super classes constructor to set the colors. Super dot underscore underscore init and then pass in color. Okay, and then we'll do self dot x equals x, self dot y equals y, self dot radius equals radius. Okay. All right, so that's circle. And then
to use the super class, don't you need to make it a subclass of shape?
You're right, I do. Thank you. That's a good catch. So circle, I need to put in parentheses shape right here. Okay, excellent catch. Otherwise, if I had tried to run that, I would have had some problems when I tried to call this super because there's no super class of that without me making it a subclass. Okay, so thank you for that. Okay, so square's got X, Y, and side length. Okay, so I think we can just copy all of this. Just copy those lines. Make a few changes here. So instead of radius, we're going to have side. I'll just call it S. And then That's S, and this is side length. Okay. All right, so that's square, and then line has x1, y1, y2. Okay, so let's add those in. Copy these two lines. All right, so we got x1, y1, x2, y2, and color. Okay, so self dot x1 equals x1. Y1, x2, oops. Y2, Y1, Y2. Okay. All right. So I think we are pretty good so far for the classes. All right. Any questions yet? Hopefully not. This should have been the easy part. Okay. Now, the circle, square, and line classes all should have a draw method, which accepts one argument, a canvas object. Okay. So in order to make, we'll start here in circle. So we'll have def draw. And then, of course, there's always going to be the self argument and then canvas. All right. This could be anything, right? It could be an integer. It could be, a lone object. So we probably want to put in a check, okay? But we don't have to. And so it says canvas is provided by tkinter, okay? It allows you to draw graphics. Okay, so this is what we're going to use it for, is to draw one of these, okay? So for the circle class, we need to use these formulas that I've given to you. Okay, x1 equals the circle's x minus the radius, the circle's y minus the radius. Okay, so I'm going to go ahead and do all of that. So we're going to do, we'll do x1 equals self dot x minus, oops, minus self dot radius. Okay, y1 equals self dot y minus self dot radius. Okay, and then x2 equals self dot x plus self dot radius, and y2 equals self dot y plus self dot radius. Okay, so I think that pretty much tracks with what's here. Okay, and then I can just copy this code right here like this. Copy. And okay. All right, so now we've got our, oh, and this needs to be canvas.createOval, okay? Now, we're of course assuming that this object canvas that's coming in has a createOval method. If it does not, then we're gonna have all kinds of problems, okay? But so for now, we'll just assume that canvas is in fact a canvas and that it has this createOval, okay? And so I need to actually change all of these to, well, no, I guess I need to change this one to self.color. Okay, so I think that is all we need for the circle method. So now I'm going to go ahead and copy all of this code. All right, and I'm going to stick it down here for the square method, for the squares draw method. And now for the square, it's going to be slightly different, right? My formulas are a little bit different. So instead of radius, all right, so let's see, radius, we're going to change this to side length. Okay, and it's going to be divided by 2. Okay, and then this, instead of createOval, is going to be createRectangle. I think, right? Yeah, createRectangle. Okay. Shouldn't color be self.color? Yes, yes. Okay, I guess you probably said that before I typed it in. Okay, so that's for square. And now for line. Okay, for line, we didn't actually have to do any transformations because the createLine method just accepts those arguments as is. So I just have to do canvas.createLine. x1, y1. Oops. Don't want to do it in the constructor. Need to do it in the draw method. Okay, so it goes here, and then I just do canvas dot create line, and then it's x1, y1, x2, y2, fill equals self.color. Is it fill for line? Let's see. Yeah, I guess it is. Okay, great. So I'm pretty sure now that this is all I should need. Let me see, is there anything else that's discussed in here? Draw method, create line. Okay, yeah, so I think this is done. All right. So let's go ahead and we'll save this. I'm going to just run it in another window. It shouldn't do anything, but if there are any syntax errors, then this should detect it. Okay, and I need to make sure I run it with Python 3. Okay, it just ran, so it doesn't look like I have any syntax errors. So everything looks good there. So now let's go ahead and we're going to incorporate all of this code into our main program, that starter code file that I gave you. Okay, so let me get out of this and we'll bring up the starter code. All right, so here's the starter code. Okay, so now the first thing that we need to do is we're going to, from assignment 6, import circle, square, rectangle. Okay. I could have just put star if I was lazy, but that's fine. Okay, and all right, all I need for that. So now, okay. So now let's see. Do I have the file? Let me make sure that I've got the file. I don't see a file called shapes.txt. So let me go download that file really quick. Oh, here it is. Okay. Copy. Shapes.txt. Okay, there we go. So there is shapes.txt. Okay, so now let's get back into this. Okay, so the first thing that it says to do is read in a file, create various shape objects, put those objects into a list of shapes. Okay, so to read in a file, we're going to do with open shapes.txt, comma r as f. Okay, and now there's a number of different ways you can do this, but what I like to do is I'm going to just say, lines equals f dot read lines. Okay, so I'm sucking all of my lines into this array of lines. Okay, and you don't necessarily have to like that. You could read it all into a single string and then split on the slash ends or whatever, but this is just kind of an easy way to do it. Okay, so now that I'm going to do for line in lines. Okay, and I'm going to do, let's see. The format is going to be the shape name followed by the parameters. Okay, so, all right, so we'll do vals equals line dot split. And before I do a split, I probably want to do a strip to get rid of that new line at the end, right? So I'll just do a strip like this. Okay, that gets rid of all the white spaces on the outside. And then I split on the comma and stick it into vals, okay? And so now, depending on what the first argument here is in my vals, whether it's circle, line, or square, that's going to determine what type of object that I create, right? Okay, so I think what I'll do is I'll say if vals 0 equals circle, okay, then I'm going to do something. If it equals a line, then I'm going to do something else. And if it equals a square, then I'm going to do yet a third thing. All right, so now All right, so the first thing that I'll do is I'll say, okay, so if it's equal to circle, then I can do x equals vals 1, y equals vals 2, radius equals vals 3. And, you could be more concise if you want to, stick it all in one line if you want, but just sort of explicitly trying to show you guys how you might do this. Okay, so then I'll say C equals circle. All right, we'll do X, Y, radius. Again, I could have done this all in one line instead of spreading it out like this. Okay, and then I believe the assignment, let's see, it said that we were supposed to create a new, so we have to add this object to a list of shapes, okay? So let's go ahead and create a list of shapes. So way back up here, before I do any of this, we'll do list of shapes equals, and it'll just be an empty list, okay? And then I will do, I need to add a color too. So the color is actually the last, I think, yeah, the color is the last item here in my list of things. Oops. Okay, so color equals val sub 4. Color like this, okay, and then we'll do list of shapes dot append C, okay? So I've now added that circle into my list of shapes, okay? So now I'm gonna do the same thing with line, okay? The only difference is that my variables will be different, okay? So let me just go ahead and copy all of this. All right, and so in this case, it's gonna be x1 is gonna be that, y1, x2 is gonna be this, y2 is going to be that, and then color is actually going to be vals 5. Okay, and then we can do, instead of this being a circle, this is going to be a line. Okay, and we'll have x1, y1, x2, y2. Okay, and then we're going to go ahead and append the list the same as before. Okay. And so then for square, copy these again. All right. So we got X, Y. This one's going to be side length. Color. Okay, so then this time we have a square. We got X, Y, side length, color. Okay. All right, so does everybody understand what we've done so far? Basically, we've taken the line, we split it on the comma, and then for each different item, when we split this first line, for example, by the comma, then we have this array or list called vals, and so val sub 0 is circle, val sub 1 is 199, val sub 2 is 236. Okay, we did this exact same thing in lab 4. Okay, if you go back to lab 4, we didn't have these exact values and stuff, but we had to open up a file and we had to read it in and split it by commas. It was pretty much identical to this. Okay, so so I didn't expect this to give you too much trouble. Okay, so now that we have this giant list of shapes that we've created, okay, it says that we're supposed to loop through the list of shapes and call the draw method. Okay, so we'll do for shape in list of shapes, and then we're just going to do shape.draw, and then it needs to have a canvas argument. Okay, so where did this canvas come from? Well, I gave it to you in the starter code. Here it is up here. Okay, so this is where canvas was created. Okay, so I can just pass this canvas into this draw method so that all of these things get drawn on the same canvas. Okay, and I think this code is pretty much done. It says, don't we have to provide the path for shapes.txt? Yeah, so as long as shapes.txt is in the same directory as this program, then you can just do it like this, okay? If you place it somewhere else, if you put it in a different folder, you know, you put one in downloads and one in documents and one in, then you would have to provide the path. But because I didn't provide a path, it's going to assume that shapes.txt is in the exact same folder that this script is in. And in fact, it should be. So let me save this and look. And so we see that here's our code right here. Okay, and then we see shapes.txt is in the same folder, so it should be able to find it. Okay. All right, well, now's the moment of truth. Now we're going to see if this actually works or not. So we'll do Python 3. Okay. Oh, no, look. I got an error. It says cannot import name rectangle from assignment 6. Okay. Does anybody know why I got this error? Anybody care to guess?
Because in the rectangle one, it says rectangle dot x or whatever instead of self.
Where is that? Rectangle.x? Where are you talking about? It's actually, okay, so that was a good guess. Actually, the reason why I can't import rectangle is because I didn't make a rectangle. Okay, let me open up another window. I'll show you. Okay. Really what I have in here is I have a circle, I have a square, and I have a line. I didn't create a rectangle class. Yeah, okay, somebody said it is line. So that's what it should be, okay? So let me just change this rectangle to line. Okay, and that should get rid of that. Okay, now I have another problem. Okay, oh, I forgot to pass color into my line constructor. So I need to do that. Okay, so that's back in here. Yep, forgot color. All right, so there's color. All right, and, oh, I'm still having more problems. Okay, it's saying unsupported operand type for minus straw and straw. Okay, yes. So that's a critical thing that I forgot to do. When you split a text file like we did over here, okay, when I start parsing through a text file, everything in vals is going to be a string, okay? And so in order to convert a string to an integer, I have to use the int method. So I have to sit here and throw in all of these ints. Okay. So we got ints for those. We need to put in ints here. Int. Close parens there. Okay. And then here we need the ints as well. Okay. And oops. Okay. All right. Let's see if that takes care of the problem. Okay. No, we still have another error. Okay. It's saying x1 is not defined. Okay. Huh, that's weird. Let's go over to line 45. Okay, we're actually, the problem is over here in assignment 6.py, line 42. Okay, so let's see. Okay, and so somebody in the chat, Amar, says, shouldn't they be selfs? Yes. Wait, yeah, right here. Okay, so in this line right here, okay, I can't just use x1, x2, I got to use self dot. Okay. It's a good catch. Self. Okay. And we know that we're going to run into that same problem up here with the rectangle as well. So, oh no, actually we won't because we created local variables, x1. Okay. Yeah, so this should be fine. All right. And okay, look, there we go. We got it working. Okay. So there you go. That was basically all there was to it. All you had to do was just kind of follow the instructions, maybe dust off lab 4, and that is basically all that there was to it. It really ended up only being, this one here is 49 lines of code, and I gave you a bunch of it. And then this file right here is 44 lines of code. Okay, so we're not talking about a huge amount of work here. So the issue was just, okay, somebody says, how would you go through the file and make a drawing out of the shapes? Okay, well, that's a good question, right? So if I wanted, let's say that I wanted to instead of just doing random stuff like this, all right, let me go ahead and close this and we'll modify shapes.txt. Okay, and we'll say, you know what? I want to actually make a picture of something. Okay, well, you just kind of have to think in your head, what is geometry like? Okay, so I'm going to try something right here and we'll see how it turns out. Okay, so let me go down to the bottom here. All right, so if we create a circle, and let's see, let's go ahead and put this at 100, 100, and we'll give it a radius of 20, and we'll do color equals blue. I think I have to do it like this, blue. Okay, so we got circle, all right. Then I'm going to put another circle at, let's see, I'm going to make this, instead of at 100, 100, let's put this at 300, 100. Okay. And then I'm going to do another circle, and I'm going to say, you know what, I'm going to put it right in between these. So I'll put this one at 200. But instead of putting it 100, I'm going to move it down a little bit. So maybe I'll put it down at like 150. Okay. And then I think lastly, I'm going to draw a line, and I'm going to draw this line from 80 to, let's say 320. And I'll put this at 200 and I'll make this red. Okay, so there we go. I'm going to just do 4 shapes. Let's see what these shapes look like. Okay, so if I run this script again, invalid. Oh, I didn't put in enough arguments for one of my things. Okay, so I need to go from 80. Let's see. So if I go from, try to think here, 8320 to 280. Go from 80, 200 to 320, 200. That's what I want. Okay. So now if I run this, hey, look, I made kind of a face. Okay. So anyway, that was a stupid answer to your question. So the answer is you basically just have to kind of visualize in your head where shapes would go, right? So if I put a circle at 100, 100, and then I put another circle at 300, 100, it's going to look like this, okay? And then this doesn't look like a very good face. So maybe what I should do is move this mouth down a little bit, right? So I could go in here and I could say, you know what, this mouth is too high. It's at 200. Let's put it down at 300. Move it down a little bit. And then if we run it, we see, okay, well now it's down too far, okay? You see, so basically, the way that I generated that file is I just basically generated a bunch of random numbers, okay? But presumably, if I had some kind of artistic ability, I could create a lot of, points and things and lines and stuff that would actually make a picture, okay? I could draw a line here, I could draw another line here, I could draw a thing, I could add, like, make a house or something. Like, there's a number of simple things that I could do. But it's basically just, geometry based on, I know that this point is 100, 100, this point is 300, 100, this was at like 150 or whatever. So this is, just basically messing around with it would be maybe how you could come up with something better. Okay. The other thing that you could do if you're really crazy is you could like use math to write like some kind of a loop to draw things in sort of a mathematical shape if you wanted to. I don't necessarily want to waste a whole lot of time doing that right now, but yeah, if you want to talk with me offline about that, I'd be happy to go over some other kind of neat like designs and stuff you could make, just using like what you know from math. Somebody said in the chat, Professor, I tried my best, but I was unable to display the required output. Will I lose a lot of points? Well, I don't know, because I don't know exactly what you did. And I'm not the one who grades the assignments. So, you know, the TA will be the one who decides. Now, what I will say is that there are certain things that, you know, the TA is going to expect. You know, for example, if you had trouble opening up the file and parsing through the file, you know, if I were the one grading it, I'd be like, come on, that's IT 109 kind of stuff. And we just did it in lab 4. Like, you should know how to do that. I would probably take off a lot of points for that, but I'm also very mean and angry. So I have no idea how Maddie is going to grade these. I guess you'll have to ask her whether, you know, you're going to lose a lot of points or not. But
If you don't have the proper output, it's usually like minus 20 points.
oh, well, then there you go. Would it be possible to ask for a rubric or a guideline, like from me or from her? I mean, I try and give her a lot of leeway to grade the way that she wants to. And so this is another reason why, and I've said this before in this class, if you are unsure of what she might want or how to grade, you need to get in contact with her, okay? And she has a lab session every Friday. Attend the lab session and just hop on there really quick and say, hey, I was working through the assignment and I ran into this thing and I was wondering whatever, right? I mean, so one of the things that I want to point out is that when you actually get into the workforce, okay, and somebody says, hey, Bob, I need you to go do this program for me, they're not going to give you a rubric, you know? They're going to say, this is kind of like how we want, this is how we want it to work and stuff. And it's up to you to just go do it, right? I mean, the only thing that you're going to have is a deadline, really, like make sure that it's done by this. And, you know, we're going to run a vote against it. And, you know, that's just going to be. So somebody asked the question, what if the lab session doesn't match your schedule? Then email her and ask for a one-on-one, okay? Both myself and Maddie are very willing to do one-on-one Zoom sessions with anybody who asks, okay? So, so we absolutely are, you know, can do that. So if, you know, and I recognize there's probably a lot of people who either don't want to come to this lecture that I give, you know, on Tuesday nights at 7 p.m. or 7:30 p.m. as the case may be. And so they can either watch it remotely, or if they have a question, you know, they're more than welcome to email me and set up a Zoom. I've had Zooms with a few students already this semester. They just emailed me and they said, hey, I got some questions about some stuff. So we have a Zoom, okay? So you absolutely can, I mean, one of the reasons why you're paying the exorbitant tuition that George Mason is charging you is so that you have access to professors and TAs to get help with your assignments. I personally think that programming is hard, okay? I don't expect you guys to be able to just plow through it as quickly as I do, because I've been doing this for 20 some odd years, you know, and you guys are undergraduate students. I don't expect you to be able to do that, but I do expect you to put forth a certain amount of effort. And when you run into issues, then you come and you talk with us, and I'm more than happy to have a Zoom with you and go through it, okay? So if, you know, for whatever reason, most students just don't want to ask for help or they're afraid to ask for questions. I don't know why that is, okay? If you were at work and somebody said, hey, you know, it's your first day at work, but I need you to refill the coffee machine, and you have no idea how to do that, are you going to just sit there and like be like, oh man, I don't know how to do it, and go curl up in a corner? No, you're going to ask somebody, hey, like, the boss told me I need to refill the coffee machine. How do I do it, right? So it's the same thing here, right? When you have an issue, when you're running into some problem, by all means, contact me, contact the TA. That's why we're here. And I like to think anyway, you guys can disagree if you want. I like to think that I'm pretty accessible. I try to answer emails, as soon as I see them. I'm not constantly checking my email, but in general, I'll respond within, a few hours, sometimes quicker, depending on when it is. And same thing, if you want to set up a Zoom, I'm try to be fairly flexible. Obviously I have a day job during the day, so I can't, just drop everything at work and do that. But, I definitely will try to accommodate. Okay. All right, so I noticed a few messages in the chat saying quiz 2 next week. Yes, okay. So 1 week from today, quiz 2 will be a thing. Somebody says there are 3 subjects. How did you arrive at 3 subjects? Just out of curiosity. Because I have actually, I don't know. I haven't looked at the schedule. I haven't written the quiz, haven't made anything. But basically the quiz is going to cover everything that we've done in the class up to this point. Now, it will emphasize whatever it was we have covered since the last quiz. That'll be most of it. Okay, so if you're saying that that's 3 subs, I'll take your word for it. But please make the quiz easier than assignment. Well, you know what the quiz is going to be like. I've already given you a quiz, okay? It's exactly, you should expect the same kind of a thing, okay? So, yeah, so the quiz will be, it'll be kind of like the last quiz. It'll be a bunch of questions that you'll have to write programs for, and the programs that you have to write will be pretty similar to the stuff that we've gone over. UML. Yeah, so I'm not going to ask you to create a UML diagram on the quiz. I think I've said this before. More than likely what I'm going to do is I will give you a UML diagram and I will say write some code based on what you see in the UML diagram. Okay. And I haven't looked at the quiz. I haven't even thought about making the quiz. I can pretty much guarantee you I'm going to make the quiz on either Monday, the day before, or probably the day of is when I'm going to actually sit down and make the quiz. And so, but I can almost guarantee you that when I see that UML is one of the topics, I'll say, okay, well, it's a pain in the butt to write UML in Blackboard using their silly web form thing. So instead, I will give you a UML diagram and ask you to write code based on what you see in the UML diagram. Okay. I can say that that's 99.9% you will get a question like that. Okay. All right. So does anybody else have any questions about the assignment or about the quiz, the schedule, anything along those lines before I start talking about the next items? If so, put it in the chat or just start talking. Okay, that's a resounding no. So I will go ahead and start talking about the next thing. All right, so this is how I'm going to do it. The first thing that I'm going to do is I am going to bring up, will you discuss the possible quiz scenarios? I mean, okay, you guys are not going to let this quiz thing drop. All right, let me pull up the course schedule and I will, right off of the top of my head, tell you what I think's going to be on the quiz. So let me see. All right. So let's see. What was on the last quiz? Does anybody remember how much stuff did we cover? I don't even remember. Somebody tell me so I don't have to pull it up, please. All the way until copy. What is copy? I don't even know what that is. Was that the multi-class stuff? Did I guys make you do deep copy stuff on the last quiz?
Yeah.
We did? Okay.
No,
all right.
we didn't do deep copy in that last quiz.
But I did copy.
Oh, yeah.
Okay. All right. So in other words, we covered up through multi-classes. Okay. So it looks like we've got UML, inheritance, polymorphism, and then we'll also have abstract base classes and duck typing. Okay. So if I was going to guess, if I was going to create 4 questions, there'd be a UML question, all right, where I give you a UML diagram and say, turn this into a bunch of Java code. Most likely that UML would include some sort of inheritance and probably a multi-class just to make it difficult. And so you'd have to write several classes based on what you see in the UML diagram. If I asked a question about inheritance, I would say create, I'd probably give you some sort of scenario, like imagine that you have a foo object and the foo object has these attributes. Then you want to create a bar object, and the bar object is a subclass of foo and it has these additional attributes, right? Create a constructor and create some method that does something and override this, right? I mean, you can imagine something similar to that. Okay, and then for the polymorphism, something similar to what we were doing with these shapes or, accounts or students, where it's like, okay, we're going to have these 14 different objects and they all have this method called blah. And so write a loop that goes through a list of these 14 different kinds of objects and calls the blah method or something like that. Okay, basically what we learned about with polymorphism. But yeah, I mean, I don't know what the exact scenarios are going to be, but again, they'll be similar to the kinds of code that you've written for the assignments and for the labs. And, based on a lot of the stuff that we talked about in class, that's the kind of stuff I'm going to expect you to know. Okay. I hope that answered your question. Like I say, I don't know what the actual scenarios are because I'm not going to bother writing the quiz until Monday at the earliest, probably the day of. Okay. All right, so let me pull up your latest lab and assignment. We'll talk about these really quick. And then if there's any time left, we'll start talking about the new material. Okay, so in this particular week, we're going to learn about two things. We're going to learn about abstract base classes, and we're going to learn about duck typing, okay? And yeah, duck typing is an interesting name. It has to do with if it walks like a duck and quacks like a duck and looks like a duck, then it's probably a duck kind of a thing. That's where that came from. Okay, and we'll talk about abstract base classes. Okay, so abstract classes are a thing in all object-oriented programming languages. Java has it, C# has it, Ruby has it. Okay, all the different programming languages have this concept of abstract classes. Okay, and so so this is kind of just an important one to know just from a general object-oriented programming. Python's implementation of it is a little bit weird, but it is what it is. They still have it. So we'll be talking about that. Yeah, that's basically just the two things. Abstract base classes and duck typing. So for the lab, you have kind of two separate things completely. One is this abstract base class and the other is this duck typing thing. So we'll be talking about both of those, okay? For the assignment, okay, because I know you guys loved this last assignment so much. Instead of having to just do these boring printout to the terminals, you got to actually draw a cool looking picture. I decided that I was going to just give you more of that, okay? So basically what we're going to do is in assignment 7, we're just modifying our classes from assignment 6. We're going to turn that shape class into an abstract class. That's actually very simple, and we'll get into that in a second. Okay. Then we're going to create a new class, which is called point. We're going to modify the circle class. This is where the duck typing portion comes in. We're going to modify circle so that it exhibits this duck typing kind of behavior. And then we're going to just replace all of that code where we're reading in the file and doing stuff with this other thing down here where we're drawing circles and creating random points and such. Okay, so we'll get into all of that, but that's basically the assignment and the labs both have kind of one section on abstract base classes and then another section on duck typing. Okay, so any questions yet? All right. So let's go ahead and dive into abstract base classes, okay? So in object-oriented programming, there is a concept of a class that you don't want to actually be able to create instances of. Okay. And you might be asking yourself, well, that's stupid. Why would you go to the trouble of creating a whole class and then not be able to create instances of it? Okay. And one of the best examples of that is actually in our assignment 6. Oops, I already have it open. In this code right here. Okay. So see this shape class? Okay. This shape class, all it has is a color. Okay. And, you know, presumably the shape could have other properties. It could have like a border. It could have a name. It could have maybe like a position in terms of like where the center of this particular shape is. If it was a polygon, it could have like a number of sides. But the point is that you'll notice that in our program, we never really actually created any instances of shape. Okay, we created plenty of instances of circles and plenty of squares and plenty of lines, but we never actually created a shape. Okay, and so the reason why you have abstract classes is typically in a situation where you're doing inheritance, where you're having superclasses and subclasses. And the point of an abstract class is just the way it sounds. It's abstract in the sense that there are a number of attributes that I want to have in this abstract class that I know I'm going to need in all of my different subclasses. So in this case, for example, we know that all the shapes need to have a color, and I know that my circle is going to need a color and my square and all that kind of stuff. And so collecting all of those attributes that are going to be common to all my subclasses and sticking them up in a superclass that's abstract actually makes a lot of sense. Okay. And so the point is, though, is that when it's abstract, that means that I cannot actually create an instance of that class. Okay. Now, I will point out that if I was to run assignment 6 as it is, okay, I'm going to run it in interactive mode so that I stay inside the shell. Okay. There is nothing stopping me from doing S equals shape and then just passing in a color like blue. Okay. It absolutely let me do that. All right. Now, I can't really do anything with this shape class because there's not really any methods. If we go and see, you know, there's this color attribute, and I can print that out. I can do s.color. Ooh, look, it's blue. But there's not really much that I can do with this shape class, okay? But Python did not prevent me from actually doing this, okay? Now, as a programmer, I might want to say, you know what? I'm not even going to allow you to create a shape class. I'm not like, if you try to do this, I'm going to throw an error. Okay. And so that's in true object-oriented programming. When you have an abstract class situation, you wouldn't even allow the user to create one of these. Okay. Isn't this concept related to the example of the user not knowing what is behind any program? Sort of. Yeah, in a certain sense it is, but it really has to do more with just design and how you design your code and how you design your classes and how you logically organize things, okay? So again, where you would use this is if you're in a situation where you have some attributes that you know are going to be common and used in a bunch of different subclasses, okay? That's where you would have them. And it's a situation by making it abstract, you're basically saying, okay, I really don't want the user to, or I really don't want another programmer to be able to actually create an instance of this. I'm only putting these here so that they can be used in these subclasses, okay? So you would create it just to share the common attributes, correct, okay? And when we start talking about abstract methods in a second, I'm going to show you that there's kind of another thing that goes along with it. Okay, so here is how, now there's a few different ways you can implement abstract methods, but I'm going to go over the way that I want you to do it for the lab and the assignment, okay? And so this is what we're going to do, all right? Maybe I shouldn't do it here because then I would just be doing your homework assignment for you. So let's suppose that I want to create an abstract class. let me see, what lecture are we on? We're on lecture, there's a lecture 10 in here. I'll make this lecture 11. Okay. All right, so I'm gonna create a class. Let's see, let's think of something fairly generic. Let's have a person class, okay? And so let's say that this has a constructor, okay? And maybe I'd have a name and an age, okay? So we obviously self.name equals name, self.age equals age, okay. All right, so this is how we're gonna make person abstract, okay? The first thing that we're gonna do is we're going to do from ABC, okay? ABC stands for abstract base class, okay? We're gonna do from ABC import ABC, all capitals, okay? Case matters in this, okay? This first ABC is all lowercase. This one is ABC, okay? And then we're also going to import something called abstract method, all one word and all lowercase, okay? So we have from ABC, import ABC, abstract method, okay? All right, now what we're going to do is inside of person, we're going to make person a subclass of ABC, okay? Just like that, okay? That's all I'm going to do, all right? Now, watch this. Okay, so I'm going to save this, all right? And if I interactive mode, Python 3, oops, it's lecture 11. Okay, I'm going to try and create a person object now. Okay, so I'll pass in a name of Bob and an age of 24. Okay, and wait, what happened? Oh, I'm not in the actual Python shell because I'm an idiot. Okay. All right, now I'm in the Python shell, so I'll do p equals person, Bob, 24. Okay, and it let me do that. It should not have let me do that. Oh, yes, it should have let me do that. Okay, so the other thing that I have to do is in Python, I have to create something called a decorator, okay? And so the way that you do it is you do at and you do abstract method like this, okay? Now, I'm not going to get into what decorators are, okay? Because it's not really super important at this point, okay? But suffice it to say, this is what you do, okay? So now I am going to try to do this again and hope that I have not. Okay, see. So now, do you see when I tried to create a person, it says, oh, you can't instantiate an abstract class person because it has this abstract method. So you're like, oh, well, okay, that's all right. Now I'm going to show you something else, okay? So let's suppose that I had another method in here called do something, okay? And in here, I'll just do print self.name plus is doing something, okay? So just a stupid kind of method that doesn't really do anything, all right? Now, if I was to create a subclass of person, all right? So now I'll have a worker, okay? And I'm gonna have him extend person, all right? So now remember, worker, because it's a subclass of person, it's gonna inherit all of this stuff. So it's gonna inherit the name and the age, and it's gonna inherit this do something method, okay? I wanna show you something, all right? So right now I'm gonna make the worker, it's not gonna do anything, okay? So if I run this in interactive mode and I say, all right, I'm going to try and create my person again. It doesn't let me, okay? Then I'm going to say W equals worker, okay? It says, oh, whoa, look, can't instantiate abstract class worker. Wait, what? Why can't I instantiate? Okay, well, remember, worker inherited this constructor. Okay, so right now worker is just the exact same thing as a person. All right, so this is what we're going to do. Okay, we're going to remove the abstract method from init and we're going to put it down here on do something. Okay, now I want to show you this. Okay, so now again, worker is just a subclass of this, doesn't do anything. If I get out of this, okay. All right. Now this is interesting. Okay. The constructor isn't abstract anymore, but the do something method is. Okay. And so now what it's telling me, the error message is slightly different. It's saying I can't instantiate an abstract class person with this abstract method do something. Okay. So as long as one of your methods in here is labeled as abstract, it will not let you create a person object. No matter what I do, I cannot create a person object. Okay, well, so then that begs the question, can I create a worker object? Let's see. Okay. Wait. Oh, no, it says I can't instantiate an. Okay. So the reason why I'm getting this same error is because I haven't actually done anything with worker yet. Okay. So let's go ahead and implement something with worker. Okay. We're going to go ahead and we're going to define a different do something method here. Okay. And we'll say print working. Okay. Now you'll notice I have overridden this method do something that's declared as abstract with this decorator here. I've overridden it here in my subclass. Okay. Now watch what happens. Okay. So if I go back in here, all right, I try and create the person. I still get this. I'm going to just get this error till the end of time that you can't instantiate it because it has this abstract method. Okay. But what about now if I try and do worker? Okay. Ooh, now it's not saying it can't instantiate. It's saying, oh, you're missing name and age. Okay. So I need to give it a name and age. All right. So, and the reason why I need to give it a name and age is because I didn't bother to give my worker a new constructor. So it's just inheriting this same one here from person. Okay. So now let's go ahead and give the worker a name. We'll make him Fred and we'll make him 198 years old. Okay. Now, look, it let me do that. Okay, that's interesting. Now, what happens if I say w.do something? It says Fred is working. Okay. All right. Well, I want to be able to create just a person, though. So I'm going to do, P equals person, Fred, and 198. Nope. Not going to let you. Okay. So this goes back to what I was saying earlier. Okay. If we go back to the assignment, and I need to be careful to not just do your entire assignment 7 for you. Okay. There's no real reason why I would ever need to create an instance of a shape. Okay. I definitely want to be able to create circles, and I definitely want to be able to create squares and lines, but I don't need to create just this generic abstract shape. Okay. Especially the only attribute that it has is color. Okay. So that, I'm not going to be able to just draw a shape that doesn't have a position, doesn't have coordinates. All it has is a color, right? I can't do with that. So this would be a perfect candidate to make it an abstract class. Okay. So if we go back to here, to make it abstract, we have to just put in this import stuff at the top. We have to make it a subclass of ABC. And then we need to mark one of the methods as abstract. Okay. But in this case, it should work since we are overriding the init. Okay. In this case, it should work because we are overriding the init. Okay. Well, so, all right. So that's a good point. Hold that thought. Okay. You're actually going to be adding a new method to shape. Okay, if you read the assignment carefully. And we'll talk about this a little bit next time because we're running out of time here. Okay, But the other reason, and very quickly, what I want to talk about, and this sort of goes to your question, okay, is sometimes what you want to do in your abstract method or in your abstract based classes is you want to define methods that you're going to require your subclasses to have. Okay. So for example, okay, I might say that every single thing that inherits from person should have a talk method, okay? Because I want all of my people to be able to talk, okay? I'm not even going to bother implementing it because I am going to declare this as an abstract method, okay? Which basically means because I'm declaring this abstract, that means I'm never going to be able to create an instance of person, and I'm never going to be able to actually execute this method here. So I'm just going to make it abstract, and I'm just going to say pass, all right? But what is this doing? Okay, let me show you, okay? If I do this now, and I go back into here, and I try and create my worker object again, okay, there's my worker. Now I'm getting this error again. It's saying you can't instantiate the abstract class worker with abstract methods talk, okay? So if I declare a method as abstract in the superclass, I am forcing the subclass to override it with an implementation, okay? And that is super important, okay? Is it kind of a private method? Kind of, but not really. It's more of, again, the reason why you would do this is you basically want to say, I am requiring all of my subclasses to implement this method, okay? So like, for example, let's suppose that I had a generic account class, okay? The account might have a name, it might have a balance, it might have a social security number, an account number, all of things that would be associated with an account. But there's no such thing as a generic account. It's either a loan or it's a checking account or it's a savings account or it's a, money market account or a CD or whatever it is, okay? And so I might say, when I'm designing this, all of my different accounts, they're going to need name and account number and balance and all that kind of stuff. So I'm going to create all those common attributes and I'm going to stick them in this abstract class. And then I'm going to say, you know what? Every single account has to have a withdrawal. Every single account has to have a deposit. So I might create abstract methods called deposit and withdrawal, where I'm basically forcing any subclass to create their own versions of withdrawal. Withdrawing from a checking account might be completely different than withdrawing from a CD, because a CD is going to incur some sort of capital gains tax if you do that, right? And so by creating this abstract method, I'm basically saying I am now forcing all of the subclasses to override this particular function. So again, this goes back to design. Okay, this is a design tactic. Okay, as I'm designing my classes, I want to say, all right, I have this concept of a person and I want all people to be able to talk. But the person itself, how he talks is going to be different. A worker is going to talk one way, a foreign exchange student is going to talk a different way, and whoever else is going to talk yet another way. And so because they all talk differently, I'm going to require that they implement a talk method, but how they do it is kind of up to them individually, depending on their specific circumstances. Okay, so that's why you do abstract-based classes and abstract methods. That's the whole purpose of it. Okay, we're 4 minutes over time. I'm sorry that I did that to you. I hate it when teachers go over. So we're going to go over a lot of this stuff again in the next lecture, and we also have to talk about duck typing. We spent a lot of time going over the old stuff, but we'll talk about this more. I would encourage you to read through the lecture. Watch the lecture videos that are out there in the course content. Read through the slides. Practice the stuff that I just went over, and bring your questions to next time. Okay. All right. I will answer any questions for the next couple of minutes if you have any. Otherwise, you are free to go. Okay, no questions. Good. All right. Have a good night, everybody. I'll see you on Thursday.